Hello and welcome to another lesson from Level Up Mathematics. This is polynomial division day 2, and in this lesson we'll be focusing on synthetic division. This is our third and final method. Now, synthetic division, it's just an alternative process to polynomial long division that can be used for problems with divisors of the form x plus a or x minus a. So it won't work with every long division problem in the world, but it will work on some. And the ones it'll work on, it's a great shortcut to know. All right. So when we're using synthetic division, we're going to, step one is find the zero of the divisor. Now in this problem, our divisor is x plus 2. So if I want to find the divisor, or the zero, I would have to subtract 2 from both sides, and I would get x equals negative 2. So that's going to go on the outside. Then you're going to make this large kind of L-shaped box like this, all right? And in the box, at the top, you're going to put your coefficients. So the coefficient for 3x to the 5 power is 3. So that would go first. Now, we're missing an x4 term. So I'm going to have to fill in a 0 for 0x to the 4th term. Then negative 8 for our x cubed term. Positive 2 for our x squared term. Negative 1 for our x term. And positive 1 for our constant term. All right. So step 2 was to set up the problem. All right. Step 3, it says drop down and then mama, mama. Now, mama, mama is just a shortcut way of saying multiply, add, multiply, add. That's what it means in this case. So what you do is you take your first coefficient, you drop it straight down. Then you're going to multiply this number 3 times this number negative 2. And whatever you get will go right here. So we multiplied, now we add. That's the mama, the MA part, multiply, add. So 0 plus negative 6 is negative 6. And you repeat that, ma, ma. So multiply, negative 6 times negative 2 is positive 12. Now add, negative 8 plus 12 is 4. 4 times negative 2 is negative 8. Now add, 2 plus negative 8 is negative 6. Multiply, negative 6 times negative 2 is negative 12. Oh, I'm sorry, I meant positive 12. And then add, negative 1 plus 12 is 11. And then multiply, 11 times negative 2 is negative 22. So whatever is left over at the end, that's your remainder. Now, your quotient will always be 1 less than the degree of the dividend. So if your dividend started with 3x to the 5, your quotient will start with x to the 4. All right? So our first number is 3. So this will be 3x to the 4 power minus 6x to the 3 power, then 4x squared minus 6x plus 11, and then write your remainder, negative 21 over the x plus 2. So there's your quotient. All right, now let's try this process again. Example 2. Use synthetic division to find the quotient of x to the 4 minus 2x cubed minus 31x minus 4. So our divisor in this problem is x minus 4 equals 0. So to find the zeros, you just add 4 to both sides. So our 0 would be positive 4. So that goes on the outside of your L-shaped box. Here's your L-shaped box. Then you're going to take your coefficients of this expression here, and that's going to go in the top of your box. So we have 1 x to the 4th, negative 2 x cubed, 0 x squared, negative 31x, and negative 4. Now we're going to start the process. We drop it and then mama, mama. So I drop the 1. Now multiply. 1 times 4 is 4. Now add. Negative 2 plus 4 is 2. Now multiply. 2 times 4 is 8. Now add. 0 plus 8 is 8. 8 times 4 is 32. Now add. That would give me 1. 1 times 4 is 4. And our remainder is 0. So our original problem started with an x to the 4 power. That means our quotient must start with x cubed. So we're going to have a 1x cubed, or just x cubed, plus 2x squared plus 8x plus 1. We do not have our remainder is 0, so that is our final answer. X cubed plus 2x squared plus 8x plus 1. All right, let's try this again where we set up the entire problem. All right, so in our next example, we have x cubed plus 4x squared minus x minus 1, and we're dividing by x plus 3. So our 0 here would be negative 3. Then you draw your big L here, and then we have 1x cubed, 4x squared, negative 1x, negative 1. Then we'll start the process of drop down, and then mama, multiply, add, multiply, add. So 1 times negative 3 is negative 3. Now add. Now multiply. Now add. Now multiply. Whatever's at the end is your remainder. So to get your quotient, because our original problem started with x cubed, my answer has to start with x squared. So x squared plus 1x minus 4 plus a remainder of 11 over x plus 3. All right, now I want you to try problem B on your own, but I do want you to note that there is a missing term. So when we set it up, the 0 here of x minus 6 would be positive 6. When we set this up, we'll have 2x squared, 2x cubed minus 14x squared plus 0x, I don't know if I put that plus in there, 0x, so we just need the 0, and then 72. All right, I want you to pause the video and try this problem on your own. When you're ready to check your answer, press play. All right, welcome back. I dropped down the 2, then I multiplied, and I added, then I multiplied, and then I added, and then I multiplied, and I added. So there's a remainder of 0. So my quotient here would be 2x squared minus 2x minus 12. Now, the last portion of the lesson is the remainder theorem. The remainder theorem is an application of synthetic division, and it states that when a polynomial is divided by x minus a, then the remainder is f of a. All right? So, when we're evaluating, say we're evaluating 3x to the 4, excuse me, minus x cubed plus 7x squared minus 2x minus 8. If we want to find f of 2 using synthetic division, I would simply take the 2 and then use your coefficients here. 3 for 3x to the 4, minus 1 for negative x cubed, positive 7 for 7x squared, negative 2 for negative 2x, and then negative 8. All right, now I'll drop this down and multiply, add, multiply, add. Let's see, 17 times 2 is 34, and add, that would be 32. 32 times 2 is 64, and then add. So that would be 56. So what we know here is that f of 2 is equal to 56. So the remainder theorem simply states that what is left over after you use the synthetic division, your remainder is f of 2 in this problem. All right? So in example 5, it says if f of x equals x to the 4 minus 7x cubed minus 9x squared minus 8x minus 5, then find f of negative 2. So we're evaluating this function at negative 2. So I'll take my coefficients, 1 for x to the 4, negative 7 for negative 7x cubed, a negative 9 for negative 9x squared, negative 8 for negative 8x, and negative 5. All right, I'll drop this down. So 1 times negative 2 is negative 2. That would be negative 9. 18. That would be 9. Multiply. Negative 26. That would be positive 52. And then we have negative 5 plus 52. So that would be, what, 47? Positive 47. So that's my remainder. So now I know if I evaluate this function at f of negative 2, I would get a positive 47. And that concludes today's lesson, Polynomial Division, Day 2.